Signal. Okay, it's good to see everybody. I hope you're having a good day today. So a couple of quick reminders. So this coming Friday by 8:05 a.m., that's the deadline if anybody wants to retake last week's right triangle trig quiz. You just need to have the completed right triangle trig homework turned in before that. Even if the day you walk into tutoring, you hand me the homework, you can then retake. Okay? It doesn't have to be like a certain time before that. So that's coming up Friday, so please pay attention to that. Speaking of homework, tomorrow we have the angles and the measures assignment due. Remember, when we say that's due, that just means I'm going to carve out a little time in class for us to talk about any questions. We have a quiz over angles and their measures on Thursday. Quiz on Thursday. Okay, so we want to be looking ahead to that. Now, hopefully this one is already in your calendars, but I'm going to keep reminding you, while this Thursday's quiz, next Thursday, that's September 4th, that is going to be the first exam of the 9 weeks. So it'll cover right triangle trig, angles and their measures, and what we're doing this week, we'll be talking about the unit circle and how to evaluate trig functions. So you'll be able to use a 3x5 note card. I'll be passing those out on Friday. That'll give you the long weekend to go ahead and start writing anything on there that you would like to. Okay. Don't forget that tomorrow during third period, we have a lockdown drill. So I talked about what would happen yesterday. Does anybody have any questions on that? Everybody knows what we would do? Okay, cool. Let's see, we got a pep rally on Thursday during 8th period, and I'm still looking for people to turn in a contract if you haven't done so, and also make sure that you've joined the College Board class. So does anybody have a contract? Okay, if you haven't, go ahead and pass it to the front. I'll go ahead and collect that from you. Okay, is there anybody else? Thank you. Okay, fantastic. I will take care of that later. All right, well, that is all I have for housekeeping items. Are there any questions? All right, well, let's do it. We've been talking about this for long enough. I think it's about time. Today, we're going to the unit circle. Okay, so this completed diagram, this is what I want you to feel comfortable with when you leave today. It looks like a lot. Okay, if we go ahead and break it down into little parts, it's going to be a lot easier. We're going to first take a look at degrees, then radians, and then coordinates. Now, as far as the unit circle goes, different people over the years are choosing different ways to approach it. Some people just straight memorize it. If you want to do that, you're more than welcome to, but with everything we have coming up in the year, that's a lot of memorizing. I would, in fact, encourage you, look for patterns. Okay? Let those patterns fill in every bit of information for you. And I'll show you what I mean when we go ahead and get there. But let's get to it. Now, it's called the unit circle because the radius is 1 unit long. Now, a little bit of a deeper dive, we're going to be dealing with some special right triangles. Okay? In fact, these two right here. The 30, 60, 90 that has leg lengths of 1/2 and √3/2, and the 45, 45, 90 that has leg lengths of square root of 2/2. You're going to notice the 45, 45 triangle, it shows up 4 times in the unit circle, while the 30, 60, 90, it shows up 8 times. What you have to remember is it's the same triangle. It might be rotated or flipped in a different position, but it's still the same triangle over and over again. Now, before we get to the coordinates, I'm going to revisit these right triangles, and we'll talk about why they have the side lengths that they do. Okay, but let's go ahead and get to it. Here is our blank unit circle. We want to fill this in. Okay, now you'll notice on the paper I gave you, there's a front and back. You've got another diagram there that you can go ahead and practice with. I've also got, this is a digital copy on the website, so you've got plenty of these diagrams if you need to. So let's start with the degrees. Okay. Now, in standard position, remember that's where we begin rotating the positive x-axis. That is 0 degrees. Okay. And let's go ahead and fill in all the information we know from the previous lesson. What's a quarter of a revolution in degrees? That's 90. So this one here is 90 degrees. Half, 180. 3/4, 270 degrees, and then we're all the way back around to 1 full revolution. We have 360 degrees. Okay, we already knew that. We knew the axes. Now, let's go ahead and focus on the cluster of points in each of the quadrants here. Now, for each cluster, each set of 3 points, they're 15 degrees from each other, but then they're 30 degrees from the closest axis. So if I'm rotating counterclockwise, this first one here, that represents 30 degrees, plus 15. 45. Because remember, in the cluster, they're only 15 degrees off each other. 45 plus 15, 60. And then plus 30, we're at 90. And we're going to continue that pattern all the way around. That's the key word. Use the patterns. Okay, so 90 plus 30, 120. Plus 15, 135. Plus 15, 150. Plus 30, there's 180. Okay, plus 30. 210. Plus 15. 225. Plus 15. 240 plus 30, there's your 270. Okay, we're almost done. Plus 30, 300, plus 15, 315, plus 15, 330, and finally plus 30, there's 360. We are already 1/3 of the way through our diagram. Okay, but typically the degree measures, nobody has any issues with that. Okay, do I have any questions though? Okay. So now, we want to go ahead and move on to the radian measures. Now, yesterday I showed you how you could take a degree measure and convert it to a radian measure. I'll go ahead and erase this right here. Now, you could do this. Like I could go ahead and take, for example, 30 degrees. Okay. What was the conversion ratio? Pi over 180. So I could go ahead and multiply every single one of those by pi over 180. You're going to get the radians, but it's also going to take time. You want a fast way to do this. Okay, so here's my first shortcut for you. Okay, looking at all these values, I want the multiples of 45. Okay, so let me go ahead and get a highlighter here. Hi. Okay. Cool. Come on in, sir. We are talking about the unit circle. Here you go, sir. Okay. So let's see. Of course, we're going to start with 45. Well, what's 45 plus 45? 90. Okay, so let's keep going. 135, 180, 225. Whoop, accidentally touched that one. We don't need that one there. Okay. 270, 315, all the way back around to 360. Okay, so I've identified those multiples of 45. Well, here's what you're going to do. If it's a multiple of 45, okay, count by fourths. Okay, so let me show you what I mean by that. Okay, every one of our fractions are going to be divided by 4, okay, but we're going to be increasing it by 1 pi every time. So at 45 degrees, bless you, let's go ahead and say, let me use purple this time. That is 1 pi over 4. Okay, now we're going to move on to the next one. That would be 2 pi over 4. Okay, but some of these are going to reduce. What's 2/4? That's 1/2. Remember, we've already known that 90 degrees should be pi over 2 radians. Okay, so that's how we're going to do it. We're going to count by fourths. So 1 pi over 4, 2 pi over 4. Next up is what? 3 pi over 4. Then we're going to have 4 pi over 4. But again, those 4's cancel, so you're just left with pi, which we know to be 180 degrees. Okay, is everybody getting the idea? Okay, so what's the next one? What's 225? That is 5 pi over 4. Okay, at 270, we should have 6 pi over 4. But what's 6/4? 3/2, 3 pi over 2. And we already knew that from the previous lesson. 3 pi over 2. Okay, so what's our count now? That was 9 pi over, so this is, or something back. Got a little ahead of myself. Okay, so that was 6 pi. This was 7 pi over 4. And then we get all the way back around to 8 pi over 4, which is what? 2 pi. See, isn't that a lot faster? Okay. And the more you work with the unit circle, you're going to become very, very familiar with these values. In fact, the more familiar you are with the unit circle, I will tell you, the easier your life moving forward is going to be. Okay. Now, let's go ahead and identify 30s. If it's a multiple of 30, and some of these are going to repeat. So first I got 30, 60, 90, then what? 120, 150, 180. Okay, so every single one of those that I underlined, those are multiples of 30. If it was a multiple of 45, we counted by fourths. Now that we're looking at multiples of 30, you're going to count by sixths. We're going to do the same thing. So 30 degrees, that's now going to be 1 pi over 6. Okay. Moving on to the next multiple, 60 degrees would be 2 pi over 6. But what's 2/6? 1/3. So 60 degrees is pi over 3. Okay. So 1 pi over 6, 2 pi over 6, 3 pi over 6. But 3/6 is 1/2. Okay. So some of these are going to repeat, and that's okay, though. Now, at 120, we're at 4 pi over 6. What's that? Okay, so that's 2/3 pi, 2 pi over 3. 150? Remember, what's the count so far? We're at 5. So this is 5 pi over 6. And then when we get to 180, there's 6 pi over 6. But there's your pi. Okay. So keep going. 210. That's 7 pi over 6. 240. 8 pi over 6. And what is 8/6? 4/3. So 4 pi over 3. 270 would be 9 pi over 6. But again, 9/6 is 3/2. So we're good to go. Okay. So now our count is at 10. What's 10 pi over 6? 5 pi over 3. Next up, 330. That's 11 pi over 6. And we get all the way back around again. 12 pi over 6. That's our 2 pi. There you go. Right there, you've now got 2/3 of the unit circle. Okay. We have all the degrees, and we have all the corresponding radian measures. Okay. Questions? Anybody having a hard time? Anybody lost? Okay. It does. It looks, yeah, because I didn't connect that too well right there. So, yeah, that's my 11 pi over 6. Absolutely. Okay, the only thing we have left is to go ahead and talk about how do I get the coordinate locations for all 16 of these values. Okay, so let's go ahead and take this off right here. Okay. Of course, it's going to be on your paper, but I'm taking mine off so it doesn't look like a hot mess. Okay. Now, why do we call this the unit circle? Because the radius has what length? It's just one unit, right? Okay. So because the radius has a length of 1, 4 of these 16 locations are going to be super easy to find. Would everybody agree that this point right here on the x-axis, wouldn't that just be 1, 0? Yeah. What about this point right here? That would be 0, 1. This point on the left, -1, 0. And finally, the point down below, 0, -1. So see, right there, you've already got 4 out of the 16. All we have left are the remaining 12. This is where the triangles are going to come in. Okay. So let's go back and review these. Okay, so here are the 2 triangles that we're going to be using. Let me go ahead and make sure that they're all on the screen. Okay. Now, what you're going to come to find out is that no matter how the triangle is placed, okay, the hypotenuse of that triangle is the radius of your circle. That's why each hypotenuse, bless you, has a length of 1. Okay. Okay, but how do we end up with like legs of 1/2 and square root of 3 over 2 in the 30/60 and 2 legs of square root of 2 over 2 in the 45/45? Well, I'm glad you asked. Okay, let's take a look. We're going to come on over here. Let's do the 45/45 first. Okay. Now, in terms of x, you might remember this from the first lesson. In fact, it was on, I believe, the very first page of right triangle trig. This is the only isosceles right triangle we have. Remember, the side lengths were x. If I wanted to find the hypotenuse, I took a leg and I multiplied it by root 2. So we have x root 2. So everybody remembers that, right? But what we're going to go ahead and say, remember, because these triangles, their hypotenuse is the radius, okay, we know that this full length right here, it's not only x root 2, but I know that it has a length of 1. I could use that to help me write an equation. Both that expression and value represent the hypotenuse. So couldn't I go ahead and say that x root 2 is equal to 1? Okay. Well, how would I solve for x? Square it. Ooh. Okay. Let's go ahead and divide through by root 2. So there's x, but that doesn't look like what was on my other slide. Am I missing something? There we go. So we rationalize it. So remember, I'm going to go ahead and multiply this by the square root of 2 over 2. Now, when I do so, that gives me square root of 2 over 2. Oh, square root of 2 over square root of 2. Because the square root of 4 is 2. That's why now, when I go back and I look at this triangle, this is why each leg is square root of 2 over 2. And the hypotenuse has a length of 1. Let's do the exact same thing for the 30, 60, 90. Now, let's start with the relationship in terms of x. So across from 30, we had our shortest leg, x. What did I do to that leg if I wanted the longer leg? I got to multiply it by something. X times what? Root 3. And then if I wanted the hypotenuse, what do I do to the leg? I double it. So that's why we had the relationship x root 3, 2x. But again, the hypotenuse has a length of 1. But 2x also represents that length. So I can use that to create another equation. If I go ahead and say that 2x is equal to 1, well, then I immediately have x is a half. So I can come back up here. That's why we had that triangle a moment ago. I can now say that x is 1/2. Okay, 1/2 times the square root of 3. There's square root of 3 over 2. And then the hypotenuse is 1 if I double 1/2. So is everybody okay with where those triangles came from? Why they have their lengths? Okay. So these are what's going to help me initially start to get my ordered pairs. Let's take a look. So I want the ordered pair at this location. Now, for any point on the circle, you're going to go ahead and create a right triangle by connecting it perpendicular to the closest x-axis. What's perpendicular mean? What kind of angle? A right angle, 90 degrees. So let's say I take this point, and I'm going to go ahead and drop it all the way down. There's my right triangle. You see how the hypotenuse is the radius of the circle? Just like I was telling you? Okay. Well, somebody help me remember. What was the degree measure of that location? Okay, what was it? Wasn't that 30 degrees? So that means this would be 60. This is the exact triangle. I know that the hypotenuse has a length of 1. Remember, across from 30 is 1/2, and across from 60, that's square root of 3 over 2. It's the legs that are going to tell me what the coordinates are. Because think back, way back in the day when you were first given a coordinate plane and you were plotting points. Okay, I want to go from the origin right here, okay, the center of the circle, and I want to move to this point on the circle itself. So don't I have to move horizontally first? Well, how far to the right did I move? Square root of 3 over 2. And then I got to move vertically up to that location. How far did I go? 1/2. See, traveling along the legs of that triangle, that gives you the coordinates of that point on the circle. And there you go. In fact, square root of 3 over 2, 1/2, if I come back over here, boom, that is exactly what we got. Okay. So now let's try it again. Let me go ahead and erase this circle here. La, 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 la. Okay. So now let's say this point. I'm going to do the exact same thing. That point, I'm going to connect it perpendicular to the closest x-axis. Always the x-axis, never the y. There's my triangle. But what's the degree measure here? What's that base angle? Ooh, not 60. This one in the middle, this was 45. Okay. See, that triangle is this triangle right here. It has the exact same measurements. So this is going to be square root of 2 over 2, square root of 2 over 2, and 1. See, it's the same thing. If I want to move from the origin to this point on the circle, I got to move horizontally, and then I got to move vertically. What's the coordinate of that point? There you go. See, we're going to continue this pattern. For each of these 12 points, I can create one of these two triangles. The 30-60 is showing up 8 times. The 45-45 is showing up 4. Is everybody okay? Okay. Now, we're only going to do this a couple of more times. So once you get the idea, that's pretty easy. But then we want a shortcut. We want to be able to get through this quickly. So we're just going to use a couple of more triangles because there is one thing I want to show you. Now let's go to this one right here. So I want this point. Again, I'm going to drop a perpendicular segment. That creates my right triangle. What's this degree measure, though? This one's 60. Now, let's see what you can remember. Without looking at your paper, I'm going to go ahead and erase this, if this will allow me to erase it. There we go. Okay. We know the hypotenuse is 1. What was the side length across from 30? 1/2. What was across from 60? 3 over 2. Along with the unit circle, you really, really want to be very familiar with these two triangles. Okay. So if I travel along the legs again, what's my coordinate? Okay. Is everybody starting to get the idea? Okay. Well, like I said, we're only going to do this one more time, okay? Because the triangles now, it kind of slows the whole process. I mean, even though we're getting the points that we want, but we're going to want a quicker way. But I want to show you one more thing. Okay, let's say I want this one right here. Okay, so I'm going to set a perpendicular segment down to the closest x-axis. Now, what's the degree measure here? If I started in standard position and I rotate over, what you're going to find, that hypotenuse, that's going to represent your terminal side. That's where you're going to stop rotating. So how far did I rotate? 120 degrees. This is why the vocabulary from this last lesson is so important. What do we call this angle right here? Started with an R. Okay. What angle is created using the closest x-axis and the terminal side? The reference angle. So if I rotated 120 degrees, what's that reference angle? It's 60. See, that reference angle is going to identify which of the two triangles you're working with. So if that's 60, this one's got to be 30. And it's the same thing. Across from 30, we have 1/2. Across from 60, square root of 3 over 2, and the hypotenuse is 1. I made a mistake, though. There's something I left out. Can anybody tell me what it is? What do you mean with negative where? Oh. Why does that have to be negative? Okay, so here's the thing. We're not saying that the side length of the triangle is a negative 1/2 unit long. That doesn't make any sense. The negative is just telling me the direction. Because see, here's the origin. I had to move left of the origin. That's why we have the negative there. Remember, X is going to be negative in quadrant 2. What's going to be negative in quadrant 3? X and Y. Okay. So if I go ahead and run through the same thing, can anybody tell me what this coordinate should be right here? Negative 1/2 square root of 3 over 2. There you go. Okay. Now, I promised you that was going to be the last triangle. Okay. So there's got to be a better way. Instead of drawing triangle after triangle to get all of these points. Okay. Well, you might have already figured it out. The unit circle has symmetry. What am I talking about? Okay. Like if I were to go ahead, for example, if I took the unit circle, if I were to fold it along the y-axis, okay, it's going to come together like a mirror image. So this point right here would be the image of this point. What's the only difference? The x value is negative. Okay, so if I run with that idea, well then by flipping this point, that image should be the one I'm looking for. Well, what should it be? There you go. And then I can go ahead and take this last point right here. I can flip it over as well. So negative root 3 over 2. That is a 3 right there. Doesn't look like it. And then 1/2. See how much faster that is? We didn't have to sit there and draw those triangles. Okay. And now we can do the same thing. I can use these points in quadrant 2. If I reflect them over the x-axis, I can have these as well. So I know that, let me get my highlighter out again. I know that this point right here should help me get this point right here. But remember I said in quadrant 3, what's negative? X and Y. So I'm going to go ahead and say that this point right here is a negative root 3 over 2, negative 1/2. Okay. And let's keep it going. What would this point right here be? Negative square root of 2 over 2. There we go. What about this point right here? There we go. Now, when you get to quadrant 4, I could take these points that I just created, I could reflect them across the y-axis, or I could take the points in quadrant 1 and I could reflect those over. What's the only thing negative in quadrant 4? Okay, the y. So let's take this point right here. If I were to flip it over, that would be square root of 3 over 2, negative 1/2. See how this is already going so much faster? Okay. The triangles are great, and it's good to know about the triangles, but use symmetry to fill it in. Oh my gosh, it's so much faster. What's this middle one right here? Square root of 2 over 2 and negative square root of 2 over 2. And our final point right there. Okay, 1/2. Negative root 3 over 2. Now you've got the completed unit circle. There we go. Okay. Degrees, radians, and more importantly, the coordinates. Okay. Now you want to see something really cool? You're probably thinking, oh my gosh, Mr. West, I don't know if I could do much more. Okay. I'm going to show you now how to get the unit circle in about a minute. All that information between 1 and 2 minutes. Super fast. Okay. Let's start with quadrant 1. Everything we know. We're going to fill it in completely. So we start with 0 degrees, which is 0 radians. This is 90 degrees, which is what? Pi over 2. That's pi over 2 radians. So this location is 1, 0. This location is 0, 1. Okay. Now let's fill in that cluster of points. What was the degree here? So that was 30. Okay. And then they were 15 degrees from each other, so this was 45, and this one was 60. If it was a multiple of 45, we counted by fourths. So 45, that's pi over 4. If it was a multiple of 30, we counted by sixths. So this was 1 pi over 6. Then we have 2 pi over 6. But that's pi over 3. Okay. Now let's go ahead and get those coordinates. Take a look at the unit circle. Now, every 12 points, not the axes, look at the 12 points contained in the quadrants. What do they all share? Every single one of them is divided by 2. So why don't I do this? Okay, let me go ahead and set this up. So I'm going to say divide by 2, divide by 2, divided by 2, divided by 2, divided by 2, divided by 2. Now, you're going to start up here at 60, and you're going to count clockwise first. You're just going to go 1, 2, 3, and then you're going to count 1, 2, 3 in the other direction. Okay, and now take the square root of the numerators. But what's the square root of 1? 1. So all you have to do is take a square root, a square root, a square root, and a square root. You've now got the entire first quadrant. Okay. And now if I want any other quadrant, this is when you start to reflect it. All right. So it just takes practice. You'll notice I don't have any notes up here. I'm doing all this from memory. So if I could do it, absolutely you folks can do this, right? Fantastic. Okay. Well, we are almost done. We're out of here at 55, right? Okay. Oh, we got plenty of time. So let's go ahead and fill in this last sheet. This is not going to take us long. So it says, what do all x values on the unit circle represent? Well, we're going to come to find out that every x is just cosine of theta. Cosine is the x variable. Okay. So what do you think the y values are? Sine. So sine is the y variable. Okay, so you're probably wondering how we could do this. Well, I'll answer that question in just a second. Remember, we're looking at a circle, right? Any point on the unit circle, or any other circle for that matter, we always label a coordinate by x comma y. You've done that forever. Well, what I'm telling you now is that any point on the circle, instead of saying x comma y, I could mark its location by cosine of theta, sine of theta. Because of this right here. X is cosine, y is sine. So here's going to be a major shift. When we're talking about right triangles, you remember we had those 3 side names? Hypotenuse, what else? Adjacent and opposite. We are no longer going to go ahead and refer to those as those 3 names. We're going to be using the variables. Okay. So for example, sine of theta is now going to be y over r. We're not going to refer to it as the opposite over the hypotenuse anymore. We're going to do it in terms of the variables. Okay. Now you're probably already wondering, well, you just said that y was sine of theta. How can we say that sine of theta was y over r? Okay, hang in there for a second. I'm going to explain it. Okay. Cosine of theta, its new ratio is x over r. Remember, because the radius is the hypotenuse. What do you think tangent is? Oh, very close. Y over x. This also gives us the opportunity to kind of revisit, some other ideas. What was the reciprocal of sine? Oh, not secant. Cosecant. So cosecant. So it's going to be the radius over y. What's the reciprocal of cosine? Secant. That's going to be the radius over x. And there's only one left. What's the reciprocal of tangent? Cotangent. So that's going to be x over y. Okay. These are the ratios we absolutely have to commit to memory. We're going to be using these throughout the rest of the year, okay, in terms of the variables. So forget about opposite, adjacent, hypotenuse. It's now x, y, and r. Okay, so x is cosine, y is sine. Okay, but why can we do this? Okay, well, I'm glad you asked. Let's say I'm going to take a point on the circle. Now, we already know that's what? How many degrees? We already know that's 30 degrees, okay? But let's do this. Let's say I'm just choosing any random point. I have no idea what theta represents, okay? Yeah, sure. Okay. Now, we have the horizontal x, we've got the vertical y, and remember the radius is the hypotenuse of your triangle, right? So let's say I wanted to create a trig equation. Let's say cosine. So I'm going to go ahead and say cosine of that angle theta, well, it equals x over r. Think about what we did in that second week. Okay, how would I solve this for x and get rid of the r? What can I multiply by? Yeah, don't we multiply by the denominator to remove a fraction? So if I multiply by r, r times the cosine of theta is equal to x. Here's the trick. Remember, we're on the unit circle. Why do we call it the unit circle? The radius equals 1. So 1 times the cosine of theta, that's why x is just cosine. Now, I don't even have to go that far. Let me show you something different with sine. If I go ahead and do the same thing, if sine of theta is equal to y over r, I could multiply through by r, but remember, what is r? 1. What's y divided by 1? So that's why sine of theta equals y. That's why any point now, I can write it like this. Now, here's where you've got to be super careful. I would absolutely have this written on your paper. Okay. If you know you're working with the unit circle where the radius equals 1, then any point xy will be cosine comma sine, just like I showed you. But we're not always going to be dealing with a circle of radius 1. Sometimes it might be larger, sometimes the radius might be smaller. If the radius does not equal 1, then your coordinate xy becomes r times cosine comma r times sine. That is crucial, but in either case, x is cosine, y is sine. Yo. Y is what? Why does it move? Oh, because, see, tangent incorporates both variables. So we have coordinates x comma y, so we're looking for the trig functions that only have x or y. Okay. So you could also do this in terms of secant and cosecant, but this is the easier path. And there you go. There's your introduction to the unit circle. What do we think? Okay. I really like the unit circle. I mean, you know, it definitely gets around. Don't worry. By the time we get to the end of the year, everything will come full circle. Okay. All right. So with that, we are done. And I am going to set up for the next class. Is everybody done copying this? Cool.